interesting as well. So I remember I told you there was no mathematical limit on dimensions. That means that 4 is not special either. So if you can imagine a 4-dimensional space, that's great. I can imagine it, I can think in 4-dimensional terms, you get used to it, you can think about it. Visualizing it is actually kind of different than understanding it and like thinking. Like you can imagine, usually you think in cross sections. But if you play around with that app I told you about, I'll tell you more about it later. Then you really get quite far with that. It's really amazing. But there's no mathematical limit. There's no reason that 4 has to be a limit. Flatlanders would think 2 is a limit. There's not. Most of us think that 3 dimensions is the limit, but that just happens to be what our universe is in. It's just 3-dimensional. It happens to be. And 4-dimensional creatures in their 4-dimensional universe would probably imagine 4-dimensional as being the limit too. They could probably more easily imagine 3, 2, and 1-dimensional space-time realities, but they wouldn't be able to understand 5 well. But if you could have those 3 perpendicular sticks, if you can add a 4th perpendicular to our existence, you have 4 dimensions. The universe could be a hypersphere, and we live on the 3D surface. What about 5? Well, you could just add another perpendicular axis. Remember, in the 4-dimensional space, there's not another direction that you could have perpendicular to the other 4, but that doesn't matter. We can just say perpendicular to the whole thing. And we cannot visualize it. We couldn't last time. We can only visualize up to 3. But that isn't the limit. That's just because we live in 3, as in the Flatlanders would only be able to see up to 2. So you could have 5, you could have 6, you could have 7. And the theory of string theory thinks that there is 10 spatial dimensions and 1 temporal dimension. I'll get onto temporal dimensions later, which is really interesting, mind-bending stuff. But that's 10 spatial dimensions, and basically, I'll get onto those later. Yeah, I have a whole section on string theory I'll talk about, which is really interesting. That says our universe is 10-dimensional, and that sounds really crazy, but it actually makes sense when I explain it later. So there's no mathematical limit on dimensions, and infinite dimensions is weird. So what would infinite dimensional space look like? So if you imagine adding dimensions to space, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on until you have infinite dimensions. So it would be like this really interesting space. It would be infinite, and it would also be infinite dimensional. That means that there would be infinity directions that would be discernible from each other. And to see how weird that is, let's look at how volume scales up with size. So if I have a glass that is like 2 glasses, one that is like, just like say this big, and another that is exactly the same but scaled up by 2, that means it's double the width, double the length, double the height. It would have 8 times more volume. So to pour from one glass into the other, I could take one full of water, pour it into the other, and the other would be 1/8 full. So that makes sense, but it's kind of funny because, it's like 2 times bigger, but it's 8 times more volume. Infinite dimensional. Imagine you have an infinite dimensional glass that holds water, and then you scale it up by not 2, but 1%. It could be any finite number scaling up. And since it would have infinity axes to scale up, that would mean it would be scaling factor would be 1.01 times 1.01 times 1.01. That would go on forever. That means the second glass, which is only a tiny bit bigger than the first glass, would be infinite times more volume. So you could fill the first glass, you could pour it into the second glass, and you would not even be able to see the water level. It would be infinitely low, it would be infinitely thin. And that doesn't matter, even if you have like the most infinitesimal, the smallest number you can think of, you add that to all the dimensions, that would still hold true. So infinite dimensional is really weird, and I'm not going to go much more into that, but just so you know, like, there's no limit on the number of dimensions, and there's no limit on what could be a dimension, or how many kinds of dimensions there are here. I'll get back to that later. That'll be interesting. Alright, now we're going to talk about dimensionally conditional properties. This is a lot of fun, so this is more just like what's possible in these dimensions, these numbers of them. Alright, so first we're going to look at turning around. In order to turn around, you have to be able to rotate, which means you need angles. So to rotate, you need to turn around, you need to be able to go 180 degrees. And you also have to be continuous. That means you cannot teleport from being like this to being like this. You actually have to go all the way around. In one dimension, that is not possible. If you have a shape in one dimension, imagine this is part of a one-dimensional line going like this. You're not allowed to just all of a sudden make it like this. It would have to go around like this, but because it's stuck in one dimension, imagine like you have a pipe, everything's stuck in a pipe. You would not be able to turn it around, so it couldn't turn around. In one-dimensional creatures in this one-dimensional environment, as weird as they'd be because it's only one-dimensional, it wouldn't be able to turn around either. However, in flat space, it is possible to turn around continuously. 3 dimensions, it's obvious you can turn around. And any amount of higher dimensions, you can turn around as well. But it's just something funny that turning around is something that's you need a certain amount of dimensions for. But we live in 3 all the time, so that's not a problem. Another thing that needs 2 or more dimensions is angles. An angle is, well, we all know what an angle is. It's like a separation between lines, or you just know what an angle is. I'm not going to bother explaining what it is. But you need at least 2 dimensions for an angle. If you have 1 dimension, you can kind of have angles, but not really. So you can have 180 degrees, and you can have 0 degrees, and all the coterminals of those. But the problem with that is that to measure the angle, you have to be able to like look at how far it can travel around. And since it can't really go from 0 to 180, it doesn't really mean anything that there are angles, so one-dimensional space does not have angles. And now for the Klein bottle. So the Klein bottle, oh, I wish I had a Klein bottle to show you. It's like this really funny-looking bottle, and its top is connected so that it goes like into the bottom, and like so you could like pour water into this part of the bottom, and so basically the bottom, the inside and the outside of the Klein bottle are all one surface. But it has.
Explain that they are real, like you can.
Yeah, real. You can build one. Like you can actually buy Klein bottles on the internet. Yeah, you can like buy these things. They're real things in our universe. You can buy them, and just look it up, Klein bottle. Maybe I'll show you a picture of a Klein bottle so you understand. It's really hard to understand if you don't see a picture for you. Yeah, that's what I'm doing. Okay. Klein bottle. There's actually this guy who makes Klein bottles, and you can like buy them from him. So these things they exist, and like this is picture 1, so you can see that you can pour water in the bottom, and you go all the way here. And notice the inside and the outside are all one surface, and that's really cool, isn't it? You just take a look at that. I'll leave this up for a while. The only problem is that there's a self-intersection that punctures part of the surface. In 4 dimensions, you could have it so that you could take this bottle and you could take this self-intersection, you could take that part, you could bend it a little bit and have it outside, and then you could have a 4-dimensional Klein bottle that is continuous, the inside is the outside, and it would all be like one Klein bottle. And you could pour a drink in it, and it would work. Only it wouldn't work at all. All the water would spill out of the sides. Now that doesn't really make sense, right? Because there'd be like a 2-dimensional kind of type surface to keep the water in. But remember, if this is a 4-dimensional drink, it's just going to spill out the sides. Now, imagine I have a glass, water, right? I pour the water in. It doesn't have anywhere to go since it's bound in these 3 dimensions. But if I have a glass that is shaped like this, that is just like this, right? Like this. Put the water in, it would spill right out the sides. Because yeah, on this plane it would be held in, but it would just spill right out the sides. So that wouldn't work. In flatland, that same glass I was telling you about, it would be able to keep the water in. The water would be in here. It would like stay in quite nicely because it wouldn't be able to go this way and this way. But in 3D, since it has that other axis of freedom, it just spills right out the sides. So that would not work. Similarly, in 4 dimensions, if we have that 3-dimensional water glass, okay, so the Klein bottle would be kind of similar, only like a funny shaped version of that. Now, if we look at cross sections, we can see one cross section, one 3D of the 4D. We would see it would be completely like you could see the whole glass at once. But if you move this way, there's no glass. Move this way, there's no glass. So water, it always tries to find its level. It always tries to go downwards. And if you have one infinitely thin slice of the area, which is 3D, that you can put the water into, it would stay there. But because if it moves a little bit this way, it can just fall onto the floor. This way it falls onto the floor. It would just fall onto the floor, and it wouldn't be able to support anything. So if you have a 4D Klein bottle, it wouldn't work either, unless you make the whole thing a 3D surface, kind of like this. But that means you'd have to cover up this little tube, and there would be another self-intersection, So yeah, you could drink water from it and everything if you were four-dimensional, but it wouldn't be any different. It would still have that self-intersection. And you could have that climb bottle I told you about earlier that wouldn't have the self-intersection, and it would be cool. Like, it would have the inside-outside you'd see, but you wouldn't be able to actually pour a drink in it. But it would be still a very cool thing to have. But you wouldn't be able